everyone, and welcome to the Bioengineered Ingredients, the Science Supports Full Disclosure session. My name is Amanda White, and I'm the Conference Content Manager for Supply Side. We have some show announcements for you. If you want to scan the QR code, that'll take you right to our show app. You'll want to download that. You can find all the session slides in our show app. And this is also being live streamed to our YouTube channel, so you can check it out there. So according to centerforsafety.org, over 75% of processed foods in the U.S. contain at least one genetically modified ingredient, yet many of those go unlabeled. With the National Bioengineered Food Disclosure Law in place, the question is, how much do we actually know about what's on our plates? I'm happy to introduce our expert speakers today. We have Karen Howard, the CEO of Organic and Natural Health Association, Alan Lewis, VP of Natural Grocers, and Dr. John Fagan, Chief Scientist and CEO at Health Research Institute. I'm going to pass the mic on to them, and we'll get the session started.
Managed to already screw this up. Amanda, which is the button to move it? Good afternoon. Thank you for joining us today. This is a subject that's near and dear to our hearts. I'm the CEO of the Organic and Natural Health Association, and I'll just tell you briefly that we are a trade association in the dietary supplement space. We're unique in that we represent the entirety of the supply chain, all the way from raw ingredients, distributors, brands, contract manufacturers, retailers, and consumer organizations. And as such, we use our platform to ensure the integrity of the dietary supplement supply chain, which includes a lot of work in regenerative agriculture, obviously organic, and the standards and ensuring those are met. So along the way, in 2018, we began working in the synthetic biology arena. Now, I want to emphasize that these are not GMOs in the old school GMO case. These are GMOs that are creating properties and entities that have never been introduced into the food or the feed supply chain. So we don't know how much DNA is from the GMO is included in any of this yet, but we're doing an enormous amount of work and research, which falls into John's lap, to be able to ascertain what that DNA is, what these properties are, what the compounds and chemicals are in the foods that really are not being tested for, and what the implications for health might be on that. When the bioengineered definition was codified by FDA, we all had an opportunity to step up and say what we thought about that. Organic and Natural Health was the only one that adamantly objected to the definition, which requires us to find DNA. And to date, no one has been able to develop that successful test for that, but we get closer and closer all the time. The global synbio industry believes that this is a fix, essentially, for a broken food chain in the world. We'll push back on that. And you can see sometimes on the floor when you walk around, we're talking to companies about how inexpensive some ingredients are that are now being made through a symbiotic process, which are much more expensive, just to sort of add to that complexity of the situation. Our goal today is to share what we believe the strategies are for introductions of these properties and into the food supply chain, what the contaminants might or might not be, and discuss some of our market surveillance around this. And we'll also share some insight on this unbridled venture-driven industry that's brand new to us, especially in the dietary supplement world, and also address effective ways to avoid and counter these reductionist solutions as we believe them to be. I think I covered that. And with that, I'm going to turn it over to John to go into the science as we know it today.
So, excuse me. First of all, thank you all very much for being with us today. We really appreciate your interest, your focus on this. It's a critical issue, one that I sort of feel like the industry is a little bit asleep on it right now. We thought we had solved the GMO issue 10 years ago, but this is a new piece of it that's coming up and has serious ramifications for the integrity of the industry. We're going to use an example today. It's one that is right out there commercially right now, and this is what's called SynBio milk. This is milk made by what has been described by the companies who are doing it as precision fermentation using, what do they call them? Microflora. Now, what that translates into in basic technical language is genetic engineering using genetically engineered fungi. Fungi are the ones we'll be looking at today, but or yeast or bacteria or algae or even higher plants or animals. But they all work the same way. And so in the first, this slide right here shows the flow of how you make a SynBio factory. What you do is you take a gene, in this case the gene for bovine whey protein, and you introduce that into a fungal cell. And that cell then is, with that gene, is capable of producing a milk protein, a bovine milk protein. But the interesting thing is that for every bovine milk protein it produces, this protein, we've measured this in 2 different, very rigorous ways. I'm happy to show the data to anybody who wants to see it. But 7 times as much fungus protein is produced as whey protein. So it's not, it's not pure whey protein that's being produced. And what they do is they put these microorganisms, these fungi, fungi into a big fermenter, and we have a picture of that here. And then they isolate the exudate from the fungi, and that contains the whey protein, but it also contains these other proteins. And as we'll see, as is pointed out a little later on, there are also about 100 small molecules, metabolites, and fermentative waste products. This is a fermentative process. These waste products from the yeast cell or the fungi cells are secreted along with the whey protein, and they end up in the final material that is moved from the fermentation into the milk bottle. So you end up with or carton, you end up with something that contains quite a mixture of materials, and you add, and that's what they call SynBio milk, or in this case, cruelty-free milk, or some very elevated terms for it. Next slide, please. So most of the ingredients in this, there are about 108 compounds there. Most of them have never been part of the human diet. They're untested for safety and for either humans or animals. And these compounds are highly abundant. These compounds are as abundant as the nutrients that are normally present in milk. But those nutrients are not present in this material. These substances are actually, many of them, we couldn't find any evidence of them being studied in the scientific literature. It's like these are part of the dark matter of biology. They may be waste products or fermentative waste products and these sorts of things. Next slide, please. And so we did very careful measurements, and what we found is that the compounds present in the bovine milk are absent or present only at tiny amounts in the SynBio milk. And the reverse is the other way. The compounds present in the SynBio milk are absent or present at very low levels in the authentic milk. So let's say you are lactose intolerant. And you say, oh, well, I think I'll do this synbio milk to replace my, my normal milk. And you think, well, you're just replacing synbio with the other. They're both milks, so you're getting the same nutrition. But that's not the case. You're getting a little bit of bovine whey protein. You're getting a whole bunch of fungal protein and fungal waste products, but you're not getting any of the literally hundreds of nutrients that are normally present in real milk. So there's no disclosure of that on the carton of the synbio milk. No disclosure. It's presented to the world as being real milk, except without the cruelty to the cows. Next slide, please. And so, and this just emphasizes what they're saying about the milk is that it's full of whey protein, like all those gold balls. But in reality, it's got a little bit of synbio whey protein, but there's mostly fungus proteins, the red and blue and green. So that's the story. And we've got science to back up every one of these things. Deep science that I'm happy to share with any of you. Thank you.
Go ahead. Yeah, thanks. In sum, what John just said is when you hear the term precision fermentation, they're describing the chaos of biology, and they're calling it precision fermentation to hide the fact that it's largely uncontrollable. And Jean's deep science, which has now been replicated in a second set of studies, is really raising the question. Now, when I've been out on the floor today, if I see a fermentation company and it says non-GMO, I ask them how it's done. So we have precision fermentation, which describes chaos, and we have non-GMO fermentation, which describes synthetic biology. It's completely upside down. And when you're talking about playful semantics and marketing or with a government agency, that's one thing. We're talking about the effects on consumer trust and consumer liability, and are consumers properly informed about what they're buying and consuming. Go ahead and move forward. So we tend to not talk about things we don't know about. So part of what we do is market surveillance, and this is, these are gonna see the notes from SymBioBeta, a global synthetic biology conference that I attended in San Jose. We're gonna start with this common quote here. Genome editing is a precision tool that is proven to be safe to grow food in a sustainable way, in a healthy way, in line with traditional breeding. This guy is a long-term with DARPA and the military and represents Professor Dudna, who claims and has patented the CRISPR process. This is kind of the state-of-the-art propaganda, if you will, the marketing of this technology. Now I'm gonna go through another 6 or 7 quotes. Is what they say when they're behind closed doors, when they're not afraid of being challenged, when they know it's all friends in the room. Go ahead. So Ginkgo Bioworks, one of the few publicly traded companies, when you look at their risk factor disclosures, they're a half-page long, all the things that can and have gone wrong with this technology. But listen to her. Biology is hard. Data to train the artificial intelligence is particularly important, and it's scarce. Partly because biology is weird. Biology does bizarre things. Precision fermentation describes chaos. Next slide. Again, behind closed doors. Zach, these are great people. Zach's really concerned about your health. He's got synthetic biology. He's engineered microbes for your gut. And then he's like, wow, these are gonna go out your toilet, into the environment, into the world permanently, and the government says we don't know what to do about that. We're not even gonna ask a question about that. He's really concerned, and yet the whole system is designed to circumvent any ability to control that. Go ahead. Pei Wu, general partner, she here is saying, look, there are consequences and impacts from this technology. Our sole focus is getting to market and monetizing. We'll sort out the collateral damage later. National Security Commission on Emerging Biotechnology, super smart, experienced person here. Companies are ready to commercialize and the regulatory system doesn't even know what to do. Regulators don't have the bandwidth. This is what's on the floor of our trade show here. We're not even aware enough to ask the right questions. Next one. Interplant, super smart person. Her partner is a Nobel Prize winner. Bioengineering plants is like writing software programs without seeing the code. And it's something AI is not going to push forward anytime soon. When she said this, even the people on stage on this big panel were like, yeah, that's the quiet part. Don't say that out loud. But these are the grave doubts from the key scientists looking at this technology. Scientists tend to understand plant engineering, biology, chemistry, biophysics. They don't get environmental effects, climate, planet effects, community effects, health effects. That's beyond their realm of knowledge, so they tend to avoid thinking about it. And here's the fun. All of this synthetic biology is predicted and guided by artificial intelligence, which is another technology that we don't have control over. It's being trained on bad science, old science. You can't differentiate between one good study or a fake study or a fraudulent study and the few good studies out there that it should pay attention to. So he's looked data sets required to really understand the question of, I edit this organism here, what is the end result? He's like, that may be a next level result, but it's an imagined result. Right now, AI is contributing to the problem and giving everyone a false sense of confidence that we can control how this technology is deployed. And my favorite, Bayer Monsanto. We are hamstrung by our limited understanding of the biology. And then a great big laugh, ha 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 ha. And the panel with her says, ha 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 ha. We are hamstrung by our limited understanding of the biology. And yet we are marketing health products and food products and animal feed products that use this technology with the collateral materials, the dark matter, the entourage molecules that John is identifying, quantifying, and in many cases saying, we don't know what these 100 materials are. Don't have a name, haven't been studied, we don't know much about them. This is our concern. There's a public acceptance in this blasé attitude because technology is good. The scientists even behind it have grave concerns, but the commercial focus, the monetization of this is driving the advancements far ahead of our willingness to address the consequences and study the consequences. My last point is, remember, this is about the shoppers in the stores consuming the products containing these ingredients. They're not going to tolerate this. Things are happening now that are dangerous and damaging. They're not going to tolerate this. So if you are a product developer or a marketer or an ingredient maker, remember the risk that we're facing. Back to you, Karen.
So I think we've made many of these points fairly clear in our position. I do want to add this to the points on this first. One, I want you to know that it's not like organic and natural health and the work that we're doing. We think we're going to put this genie back in the bottle. We all know that's not possible. We also know that GMOs have become a major component of what we have successfully been able to do for our consumers in this industry by getting rid of them in the supply chain. So disclosure is really what we're after, disclosure, so that people understand that these products are made with GMO inputs that are destructive to the ground and the environment. That won't go over well. And I'd like to also emphasize that the price differentials that we get to make this industry financially successful and enable shows like this is based on a price point that's fair and reflects the quality that people put into the work to create really good products, so that allowing these ingredients into the supply chain really undercuts the value of the work that we do, and subsequently, most likely, this whole outcome of what is the entourage effect that we don't know about. So I think those are really critical points. And I would also like to add that right now, the only saving grace that this industry has is the use of self-affirmed grass. So I would believe there are a lot of problems with self-affirmed grass, some of which are easy to sort of suss out, others which are much more complicated. I do think that this is a more complicated process for grass. And I don't think at the end of the day, given the science and the amount of work that's going into this on our part and other people, that that's going to hold. And I would also add to that, this is not doable in Europe. They have a very different GMO standard, and this has not been successfully introduced into the marketplace there. So there are barriers to entry in certain parts of the world, and yet the proliferation of the development of these unknown outcomes seems to continue to rise. So it's really, in our perspective, it's an education effort, and it's a scientific process that we are striving to make sure we can be successful so that disclosure is required. We are very adamant about consumer safety and consumer health. That really is what drives organic and natural health, and that's really where this is coming from, not from a place of fear or an education.
Thank you all very much. Appreciate your passion. Love what you guys are doing. I'll just take the clicker. We did ask Perfect Day for comment, and as I was sitting back there listening, I was like, maybe we should have debate style panel with precision fermentation and you all, and then I was like, well, I don't volunteer to moderate that one. But the comment from Perfect Day for just some of the points that were brought up in the session, I'm not going to read it all, but they, had something to say for some of these points as well. So most ingredients have never been part of the human diet before. They said the process Perfect Day uses is to produce whey protein identical to what is found in naturally occurring milk. Find a shorter one here. So maybe contamination left over from fermentation steep. Perfect Day's technology uses several filtration steps to remove all impurities. Our product has been tested since the start of the launch in 2019 to ensure it meets excellent food grade quality. So I'm going to let them respond. Again, these slides are in the app, so if anyone wants to check those out at any time, you can. But you guys can go ahead and respond, and then we'll go to the audience for Q&A.
Great. Thanks for your patience. We weren't expecting this. We're not quite sure how these appeared in this kind of presentation, but we'll respond to them. I'm not going to read each of these because that would take up all the time. So I'm going to read my response, and you can look at the screens and see what I'm talking about. So for the first one, the synbio production process does produce whey protein, but it also produces 7 times more fungal protein than whey protein. Additionally, along with the fungal protein, the synbio product contains about 100 metabolites and waste products secreted by the fungus that have never been tested for safety. These could be toxic, they could be allergenic, or they could be disruptive of your microbiome or other parts of the digestive system. The second one, untested for safety for human and animal consumption. The developer of this product makes it sound as if the FDA has awarded them a GRAS status for their product. But this isn't the case. They made a self-affirmed GRAS statement, which they submitted to the FDA, and the FDA said, oh, okay, so you think it's safe. Well, don't forget, if somebody gets sick from it, you're responsible for it. The developer based its GRAS affirmation on, not on safety testing actually, but they referred to an earlier GRAS statement that was for the same microorganism, but to produce a very different product, an enzyme. And the difference is that whereas with that enzyme there were literally micro or nanograms of that fungal protein in the final food that people would eat, it's grams of these fungal proteins in the Synbio milk, about 7 grams for a cup of milk. So it's a very different story. That grass is probably why the FDA reminded them that they better be prepared to deal with any problems that come up. Next one, substances often unknown to science. Actually, there is a special proprietary ingredient present in the Synbio milk, and that is the genetically engineered fungus. That fungus secretes whey protein, but it also secretes all this other fungal protein and 100 metabolites and waste products. So it isn't like a pure whey protein that goes into the Synbio milk. It's this mix of undefined materials that have not been tested for safety. So it's a crapshoot. And the last one is maybe contamination left over from fermentation steep. It really follows from what we said before. The developer says they remove contaminants by filtration. Filtration will not remove molecules. It doesn't remove the fungal proteins, and it doesn't remove the 100 metabolites and waste products. Those end up in the final product. And we actually measured them in the final product that we had purchased online. It can also be, you can get this stuff in Target almost anywhere in America now. So go out and give it a try. And if I'd love to know what your experiences of it is. So anyway, those are answers to those questions. And it requires deeper thinking than the marketing section of a company is capable of giving. This requires serious thinking about the responsibility of the company to the consumers who they're selling products to. What does it mean when you call it a microflora when in fact it's a genetically engineered fungus? What does it mean when precision fermentation actually means a very sloppy process that puts all sorts of weird things in your cup instead of milk? Thank you very much.
Thank you, everybody.
Do we have any questions?
So let me understand this. They submitted to the FDA a review of their request to become GRAS. That's a 6-month process. And during that time, their toxicologists had no objections, and so they've allowed it into the marketplace. That's the reason they would be GRAS, if they're allowed to do so in writing by FDA. And if that's the case, I'd be very interested, I think everybody here would be, what is EFSO's response to this very question, because you said earlier that they have decided not to allow this to be introduced in Europe, and I think we'd all be very interested on the basis on which they made that decision, and then compare that to what FDA should have done if they didn't.
Yeah, it's very interesting. And the thing is that when you do a self-declared GRAS, you don't even have to show it to the FDA. It's just out there. Now, they were so bold as to submit it to the FDA, and the FDA said, okay, so you think it's safe. Yeah. They didn't look at it critically. That's the shocking thing to me. This is the problem with the self-affirmed GRAS.
I am CEO of AIBMR Life Sciences. We probably have done more submissions to FDA for GRAS than any entity in this industry. And I know the degree of experimental evidence we need to provide And the review we go through, by the way, by our chair for our expert committee,
Yes, uh-huh.
is the former head of toxicology at FDA and EPA. And I know how rigorous our staff work, who are all physicians and toxicologists, before we send anything to FDA for their review.
Well, you look at that GRAS statement, and there is no science described in there other than referring to this earlier GRAS statement by a company that was using T. reesii to produce an enzyme. The difference in the amount of fungal protein in the enzyme, you put the enzyme into a product and then you process it and you end up with a food that has a little bit of fungal protein. It's literally 33,000 times lower than the amount that is present in the SynBio milk. It's below the level that would be considered allergenic for any protein on the planet.
I'd encourage you to look at also the Impossible Foods GRAS statement, because they disclosed 45 unexpected proteins, quote unquote, and the FDA said, "Ah, shucks, well, we're not granting GRAS status, but you are. Good luck with that." But 45 unidentified proteins that could have short or long-term health effects, we think significant to shoppers, right?
I should send, if you go to our website,
Can
we
you
have
speak into the
many of the self-affirmed on our website. If you want to find out, in fact, that's what FDA uses to find it, and it's not on our list, this SynBio,
Yeah.
which really disturbs me, because I think that's the reason we created that list, so that consumers in the industry would know what's self-confirmed, because they don't have to tell FDA, but we can find out ways in which things have been self-affirmed and added to the list. I also know that when they issue their letter after their 6-month review, it should be the basis on which they made their decision, describing exactly what they looked at and reviewed. So it's not a 1 or 2 page letter. It can be 8 or 15 pages long, you know, itemizing every single document that they looked at. And that's the reason they came to the following conclusion, either to allow it or not to allow it. But this sounds really strange, and that's very disturbing.
Yeah. Well, I am the FDA response to that. Have you seen the FDA response to that letter or to their GRAS?
I mean, you're right. In this case, it's very short, and they said, look, milk protein's been in milk supplies, so we're going to say we don't have any questions about your milk protein. They ignored everything else in the entourage.
That's what I was thinking, because I did not see an eight-page letter.
I
And,
think the other interesting thing about that is that any organization in the United States that is following ESG requirements will not go anywhere near this. They are avoiding it completely. So that it's not in publicly traded companies at this point because of the risk factors.
I'm afraid that's all the time we have.
Thank you very much, everyone.
thank you. We really
Thank you
appreciate
all.
the question.